Okay, let's get right to it. Again, day 2 of these regular polygons, but what happens when you don't have a 30, 60, 45, 45, and Pythag is out the window? All right, what do I rely on then? All right, first one here, you got a regular pentagon. I want to find the area. So whether you want to do 5 triangles, fine. I'm going to do 1/2 AP though. If you want to break it up into 5 triangles, fine. Regardless of which way you do it, you got to remember you're still going to find the apothem. 1/2, because the apothem is the same as the height if you do it by 5 triangles. All right, so regardless of which way you find the area, you're still going to have to find the apothem. What's labeled as 10? That's the what of the pentagon? That's the radius, okay? No big deal. Can you guys start finding some angles, please? That's the first start here. Find some angles in those triangles. All right? You guys should, at this point now, know how to find angle QPR. And then you know the apothem bisects it. So go right ahead. Try to find some of the angle measures inside. Okay, I want to hear from some groups. What angle measures are you finding? Okay, here you go. Oh, I guess not. All right, let me just hear from anybody here. QPR. What'd you find, Sad? How'd you get 72?
I divided
by 5, yep. So that's going to give me 72, which means half the angle's got to be 36. Okay, you could have found angle PRS as well. It's up to you. All right, guys, I don't know a 36, whatever that angle happened to be, 90 triangle. Don't know it. Don't know the rules. Don't even know if any rules exist, to be honest. But still have to find that apothem. And RS so I can find the perimeter. Has there been anything we've done this year, a whole unit? If I have a right triangle and I have a side, try to find some other sides. And Pythag isn't going to work either because you only have one side. There's a couple different methods we used. It is a right triangle. I could use SOHCAHTOA. Or anybody else? I have 2 angle, actually I have all the angles. One side trying to find another side. I could also use what if SOHCAHTOA? I'm not feeling SOHCAHTOA. Law of sines. Yeah, I could use law of sines as well. It's up to you. All right, and I don't want to just throw this out there. I want you, and that's why you and your group are together right now. Okay, so go right ahead. I'll leave this up to you guys right now. It's going to be wide open. All right, wide open. I'll give you guys about 2 or 3 minutes to solve this. We'll go over it together. Don't round anything until the end of the problem. Do not round anything until the end of the problem. Let's see what you got. All right, there's a lot of discussion out there, a lot of different ways to find the different sides. Let me just open it up to one group only. 7, you and your group, what did we end up doing?
I did law of sines.
Okay, what are you trying to find first so we can identify?
RS.
Okay, so RS, you can use the law of sines by doing what?
I did 10 over the sine of 90, which is 1.
10 over sine 90, got it, equals?
X over the sine of 36.
Okay, this is one way you could get to RS, one way. Okay, one way you could get to RS. And that should have ended up being, what'd you guys, 5.8, 778, 52, 523. And again, one way. You could have used, let's see, you could have used sines. You could have used cosines if you wanted to in SOHCAHTOA. All right, you could have used sine or cosine in SOHCAHTOA to do this. All right, how do I go from here to the perimeter then? Because that is just RS. I need the full perimeter. So what should I multiply 5.877 da-da-da by? Multiply it by 10. Yep, because there's 10 of these half segments all the way around. So I multiply it by 10, and I get a perimeter of, I just moved the decimal point over, 58.77852523. Still not rounding a darn thing. All right, let's go to another group. How'd you guys get PS, the apothem? Everyone should have had to find PS no matter what method you use. 12, how'd you and your group find PS? Oh, I want to hear another group. 13? Okay, already. I'm ready here. I'm going to call this side Y now, everybody. All right, I'm ready there, Katie. Okay, 10 over sine 90. Yep. Nice job, over sine 54. Again, you could have used sine, you could have used cosine to find Y. And that should have ended up being, let's see if my calculations are correct, 8.090169944. We all good there? Now I have enough information to plug into 1/2 AP without rounding anything. There's my apothem. There's my perimeter. And to the nearest tenth, I have 237.8 square inches. Everyone okay? Going. Okay, hold on before you get to the octagon one, because here's how the rest of class is going to go. I'll give you the answer for the octagon one, and then I'm going to tell you what regions problems I want you and your group to try out. Okay? And then we'll go over them at the end of class. All right, the area of the octagon on the next one, and then that segment 8 is perpendicular to the side. I'll tell you that right off the bat. All right, that segment of 8 inches is perpendicular to the side. Is 212.1. That's the area of the octagon, 212.1. Can you guys get your Regents exam out that you got as you came in today so you can know what numbers to try out when you and your group get 212.1? Yes. I'll be right over. Okay, everyone ready on the Regents exam? You're going to do 7, 10. And we're going to hopefully go over these with about 5 minutes left. You're going to go 7, 10, 13, and put your heads together for number 29. Okay, so again, 29, 13, 7, and 10. After you get 212.1 for the octagon. All right, if you cannot get 212.1, that's when you raise that paw of yours and give me a call over. Circle B, arc length in circle B. 13 pi over 8 equals theta times 6.5. Divide both sides by 6.5. And notice in circle A, what did I have in my angle in circle A? I still had pi, right? So I still want to keep the pi here. So here's what I'm going to watch. Here's what I'm going to do in my calculator right now. 13 over 8. Go to my fraction template. I'll have to make another one. I'm going to go 13 over 8 divided by, I'm going to keep the pi out of there. So I'm going to divide that by 6.5. 0.25, if you need to turn it back into a fraction, go ahead, but 0.25 is the same as 1/4. So it ended up being pi over 4 as well. And notice what's the last two words there of that problem. Explain. Remember, explain is your work's not good enough. That's justify. You can leave your work if it said justify why, but explain why. Write a sentence or two telling me why they're equal. Okay, both of them, both angle A come out to be pi over 4 radians, which is the same radian measure. You have to write some kind of concluding statement. I don't want to get into it, but does everyone remember there was another formula for degrees? In degrees, measure of arc over 360 times the circumference. You could, hey, I'm just throwing this out there. You could use this formula, solve for the measure of the arc, but at the end, what do you got to convert it into? Because this will be in degrees. You got to convert it into radians. So that's the other option here. All right, is use this formula, solve for the measure of the arc, which is equal to your central angle, and then convert it in the radians at the end. Yep.
So what did you write for the explain why that's not just restating that they're equal? I'm not exactly sure what I should do.
Both circle A and circle B came out to have a central angle of pi over 4 radians. You just need you need like a summary statement for your work.
All right, so
The work alone is not good enough when it says explain. Okay, the work alone. Or you could say using the formula S equals theta R, we found both circle A and circle B had central angles of pi over 4. So Dominic is correct, because that was the actual question. Is he correct or not? Questions? All right, let's keep working backwards then. 13. I saw a couple people scratching their heads here on 13. Altitude SU. SU is H. UT is 12. RT was 42. What value of H will make RST a right triangle? Hey, diagram alone should signal some bells in the head. Diagram alone. You want to make RST a right triangle, and you have an altitude drawn to the hypotenuse. This automatically anytime I'm given this type of diagram, right triangle with an altitude to the hypotenuse, Hill SAS. What are you guys solving for? What's H labeled as? That's the altitude. Discussion's over. Which one of the two should I be using? Yep. Segment 12. What about the other segment? Not 42. 30. Be careful. I'm sure that multiple choice answer was there if you used 42. H over 30. H squared equals 360. And I look at the choices. You got to have to break it down. Anybody find the perfect square that goes into 36? Yeah. Or 360. How about that? 36 and 10. 6 radical 10, yes? 6 radical 10. Okay. Amanda, Maya, Nate, got to shoot. Circle quiz 3. Circle quiz 3.